We just learned what a sequence is. It's a list of numbers basically, and each number is named as a term of the sequence. The first number is the first term, second number is the second term, and so on. And the notation for writing a sequence is something like this. So in this video, I will talk about some special types of sequences. So the first type we say are what we call bounded sequences. Now, a sequence can be bounded on both sides, or it can be bounded below or can be bounded above. So for example, if we look at this first one here, the values we are getting are just -1, 0, and 1. So we are not getting anything below -1, not getting anything above 1, which means it is bounded from both sides. If you look at the next sequence, which is 5, 8, 11, 14, 17, and so on. So we say this is bounded below because it is starting at 5, but then the higher we go with the n values, we are going up and up and up. So it's going towards infinity. So we say it is not bounded above, but it is bounded below. Now the next one, 1/2, 2/3, 3/4, 4/5, 5/6, and so on. So if you notice each value, if you take a calculator and compute them, so you will notice as n moves on, as n becomes bigger and bigger, that each term becomes smaller than the previous term. So it is kind of a decreasing sequence, and it looks like it is going towards 1. So we say it is bounded above because it is reaching a certain value. The next type of sequence is what we call increasing sequence. So an increasing sequence is something in which every subsequent term is greater than or equal to the previous term. So next term is bigger than the previous term. So then we say it is an increasing sequence. So these two are examples of increasing sequence. Decreasing sequence is one in which the next term is less than the previous term. So each next term is less than the previous term. So that is what a decreasing sequence is. Alternating sequence, I already mentioned this, a sequence in which subsequent terms have opposite signs. So now the next thing we want to see is when can we say a sequence is convergent or when is it divergent. One thing we learned in the previous video, that if this limit exists, the limit of the nth term as n goes to infinity exists, then we say the sequence is converging, and if it does not exist, we say the sequence is diverging. So when will this exist? So theorem 1 is giving us the criterion for existing of the limit, that the limit, when will the limit exist? So we say that if the sequence, whichever sequence we are considering, it is increasing and is bounded above, or if it is decreasing and is bounded below, then we say that the limit a sub n as n goes to infinity exists. So the next theorem is about the alternating sequence. So when we have alternating sequence, then what happens? So we are not talking about actually the existence of it gives us an idea like when will the limit of alternating sequence exist and when will it not exist. So we notice that if we have an alternating sequence and if the limit of a sub n as n goes to infinity is 0, the absolute value. So we are looking at the sequence with all positive terms. So same sequence, but all terms taken as positive. So if that happens, then we say that the limit of the actual sequence will also be equal to 0, which means the limit will exist and the sequence will be convergent. But if the limit of the absolute value of the sequences, which means the limit with all positive terms of the sequence, is not equal to 0, is equal to a number, for example 1 or 5 or 10 or any number, then we say that the limit does not exist or the sequence is divergent. And also if this limit does not exist, like it's coming out to be two different values or coming out to be infinity or minus infinity, then we say that the sequence is divergent. So let us look at how do we find the limits of these sequences below. So note that when we are studying an alternating sequence, we are first going to look at the sequence with all positive terms, which means we are looking at the sequence by dropping the negative terms. So our sequence here, an, in this case, is this. So what will be the sequence with an absolute? So this will be 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. So you can see what is happening, that the a sub n absolute is going to look like 1 over n. So now we find limit of 1 over n as n goes to infinity, and this comes out to be 0, we know that. So this is actually sequence converges, and limit and the limit of the sequence and limit of the sequence is 0. Okay, looking at the next example, so here you can see the an here is -1 to the n times n over n plus 1. So the absolute of this will be equal to, maybe I'll write it over here, absolute of this will be equal to just n over n plus 1. So what absolute does, it drops the negative sign. So now we want the limit of this thing, which means limit n goes to infinity of n over n plus 1, which we know is going to be 1, because remember how I explained, you will divide by n, top and bottom, and this is going to give you 1 over 1 plus limit n goes to infinity 1 over n, which means 1 over 1 plus 0 or 1. So because this is not equal to 0, so the limit or the sequence diverges. Okay, looking at the next example, so again an in this case is -1 to the n, ln of n over n, and we will be looking at the absolute of a sub n, which will be equal to ln over n. So we will now find limit as n goes to infinity of ln over n. And how do we find this limit? Well, remember again we have to use the L'Hopital rule. So in this case you notice this is infinity over infinity form. So by LH rule, this will be limit as n goes to infinity of 1 over n divided by 1, which after simplification gives us and which is equal to 0. So the sequence with the positive term goes to the limit of the sequence to the positive term is 0. Therefore, the limit of a sub n of this sequence a sub n will be equal to 0. So the sequence converges. Okay, so this is how we look at how the sequences converge. So we looked at different types of sequences. So let's see what we will look at next.